Hi guys, you welcome back to my channel. In today's episode of our video, as we have commenced the 9 days organic chemistry class, there is another episode of one of the topic promised that I will drop under the 9 days organic chemistry class. So guys, come closer. What do you have on the board today? We have alkanoic, and we can as well call it carboxylic acid. And what are alkanoic? They are organic compound containing a carbonyl group. This is a functional group. This is a carbonyl attached to the hydroxy group. The functional group of the hydroxy is what? OH. And one thing you need to know is that when we talk about this alkanoic acid, or we look at the carboxylic acid as a whole, there are things you need to understand as far as this is concerned. We have the general molecular formula. They as well belong to the homologous series. And how do we take a look at this? You need to understand the fact that when this carbonyl and the hydroxy group combine together, they give us the functional group of carboxylic acid or alkanoic. So let's take a look at that. The functional group of carboxylic acid is known to be this, and we have what? OH. Don't forget, this is the carbonyl. Why this is what? Hydroxy. So it means that for every carboxylic acid or for every alkanoic functional group, they contain two compounds, which are the carbonyl group and the hydroxy group. So with this now, they as well belong to what we call homologous series. Homologous series with general molecular formula CN H2N plus 1 COOH. And when we come to the naming of this carboxylic acid or alkanoic, the ANE of the alkane is being replaced with IOC. So meaning that if we are to name any organic compound under this carboxylic, the first member is ethanoic acid. So if you observe vividly, we can as well say this is ethanoic acid. And we as well have methanoic acid. But the first member, as far as carboxylic acid is concerned, is ethanoic acid. But in some cases where you come across having methanoic as the first member, you can as well take it like that. But not one thing, that anytime you have to start the carboxylic acid or the alkanoic, the first value is when n is equal to 1. That will take us to what we call naming of alkanoic. Naming of alkanoic. And if you are to name this alkanoic or carboxylic acid, you need to obey the general molecular formula, which states CN H2N plus 1, then the functional group. So let's take a look at when n is equal to 1. Using this particular formula, we can say we have CH3, because if we are to take this n into this formula, the n here will be replaced with 1, and 2 times 1 is what? 2. Plus 1, we have what? 3. So the functional group is what? This. So this is called ethanoic acid. The next one is when n is equal to 2, we have C2. 2 times 2 is 4, plus 1 we have 5. OH, this is called propanoic acid. The next one is when n is equal to 3, we have C3H7. So the main reason why they made mention that they belong to the homologous series is that if you have to take a look at this now, the next compound or the next formula that will be added to this CH3, for example, under this homologous series, I have CH3. So how did they belong to homologous series? The moment I'm adding this plus CH2, C plus C will give us C2, CH3 plus H3 plus H2, we have what? H5. So the difference between ethanoic and propanoic is what? CH2. That is why we can say that the carboxylic acid or the alkanoic belong to the homologous series. Are you with me now? So the next one is, we have when n is equal to 3, it is called butanoic. In some cases where you come across metanoic, the general molecular formula for metanoic is H, the functional group, then this one will give us what? Metanoic. But note one thing, that the first member of carboxylic acid is ethanoic. In some cases, when we talk about the classification of the alkanoic or the carboxylic, when we have X, Y, and Z, then we have our N, then the functional group. Those X, Y, and Z will be discussed in our next class. But come closer, when we have N is equal to 4, we have C4, homologous series, we have 9. So this is called pentanoic acid. Then the next one, when n is equal to 5, we have C5H11, the functional group. This is called hexanoic acid. Now, I will stop here. The next one will be heptanoic, octanoic, nonanoic, and decanoic acid. So when we have, when n is equal to 6, C6H13, COOH. If you look at the difference here, the difference here is what? Adding CH2 to this, we have this. 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 Adding CH2 to this one, that will be C7H15. So when n is equal to 7, we have this. So the functional group, this will give us, we have, this is what? Hexanoic. We have heptanoic. We have octanoic. So when you take a look at this now, the first one is ethanoic acid, this. The second one is propanoic. We have butanoic. We have pentanoic. We have hexanoic. We have heptanoic. And we have octanoic. In some, you'll be like, how do we have CH3 with the functional group, which is COOH, to stand as ethanoic? Mind you, when you go back to the parent alkane, our ethane having ethanoic always have what? C2. Now, let's take a look at another way of having this ethanoic acid. If you add this to this place, we'll be having C2, then add your H to this, we have CH4. Then how many oxygen left? We have what? O2. So if you come across having your ethanoic like this, you should be able to differentiate which one is ethanoic and which one is propanoic. So for this now, adding this one to this, we have C3H. Adding this H to this place, we have H6 and we have O2. Are you with me now? That tells you that our ethane did not change with 2 carbon atoms. Our propane did not change with 3 carbon atoms. Irrespective of how you place it, just note the rules that governs how to name the organic compound, because each of the organic compound have the rules of how we can easily deduce the compound name compared to inorganic. But organic chemistry, each compound has their rules under the IUPAC to name each compound. But not one thing, for every alkanoic or carboxylic, you must always consider the numbering from where you have the lowest number attached to the functional group. And what is the functional group of the alkanoic? It contains both carbonyl group and the hydroxy group. Is that clear now? So guys, this is the introduction to alkanoic acid. we'll take a look at the definition of alkanoic, we'll take a look at the functional group, the general molecular formula of the alkanoic, then we'll move to the naming of alkanoic. If you are just coming across this video, do well to watch it and comment. And if you have any question you want to ask, do well to drop it in the comment box. Thanks.